Hello, good morning. Factors influencing chemical shift. There are four factors influencing the chemical shift: electronegativity and inductive effect, hydrogen bonding, van der Waals shielding, anisotropic effect, space effect. Nature of groups: electronegativity or inductive effect. Atoms and groups which are electron withdrawing decelerate the protons. Electron withdrawing negative inductive effect. These groups reduce the electron density around the proton or decelerate. The proton, thereby resulting in downfield absorption. Electron releasing groups increases the electron density around the protons and result upfield, that is the shielded. In case of fluoroethane has two types of protons. The protons level A are the more deshielded. Then protons level B because of different distance of chlorine from the two types of protons. An electron withdrawing group is able to reduce electron density around the proton and deseals the proton. An electron releasing groups increase the electron density around the proton and give rise to its shielding. Anisotropy space effect. In compound containing double or triple bond, circulation of pi electrons about nearby nuclei generate an induced field which can either oppose or reinforce the location of proton or the space occupied by the proton. In compound containing double or triple bond, circulation of pi electrons about nearby the nuclei generates an induced field which can either oppose or reinforce the location of proton or the space occupied by the proton. The occurrence of shielding or deshielding can be determined by the location of proton in the space, and so this effect is known as space effect. Aromatic proton, delta 7 to 8 ppm, circulation of electrons, ring current. Induced field reinforce the external field, deshielding, induced magnetic field. Vinyl olefinic protons, delta 5 to 6 ppm, induced field reinforce the external field, deshielding. Aldehyde protons, induced field reinforce the external field, deshielding. Hydrogen bonding. If an atom exhibits hydrogen bonding in a compound, it will deshield it due to the strongly negative atoms attached to it. So absorption is shifted downfield. Van der Waals deshielding, the electrons cloud of the bulkier groups will tend to repel the electron cloud surrounding the proton. Thus, such a proton will be deshielded. Electron cloud of bulkier group will tend to repel the electron cloud surrounding the proton. It will resonate at slightly higher value of delta than expected in the absence of this effect. In overcrowded molecules, it is possible that some protons may be occupying strictly Indral's position. Clearly, electronegative cloud of bulky groups, hindering group will tend to repel the electron cloud surrounding the proton. Thus, such a proton will be decelerated and will resonate or slightly higher values of delta than expected in the absence of this effect. This is considered as van der Waals desilting. Types of protons, chemical shift, primary proton 0.9 value of delta, value of tau 10 minus delta, so 9 minus 1, sorry, 9.1, secondary 1.3, tertiary 1.5, vinylic 4.6 to 5.9, acetylene 2 to 3, aromatic 6 to 8.5, benzylic 2.2 to 3, allylic 1.7, alkyl fluoride 4 to 4.5, alkyl chloride 3 to 4, alkyl bromide 2.5 to 4, alkyl iodide 2 to 4, alcohol 3.4 to 4, ethers 1.3 to 4. Carbonyl compounds 2 to 2.7, acids 2 to 2.6, hydroxylic 1 to 5.5, phenolic 4 to 12, aldehyde 9 to 10, carboxylic 10.5 to 12. Approximate chemical shifts range for the selected types of protons. These are already discussed. Also, you can represent the chemical shift in this table. Okay, it's all about factors affecting chemical shift or factors influencing chemical shifts with the value of delta. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for your patience. That is now bye-bye.